Hello everyone. In this video I am going to explain the assembly level program for in 8085 for comparing numbers. So first we'll see how to find out larger and the smaller of any two 8-bit numbers in 8085, means ALP in 8085. Then we'll see to how to find out the smallest and largest of any n array of or n from the array of 8-bit number. Then in the third category we'll see how to arrange an array of 8-bit numbers in ascending and descending orders. Okay, let's start. So let's start. First we'll see how to find out the larger of any two 8-bit number. Suppose the first number, so to compare there are two numbers. The first number is suppose stored in 2050 memory location, which is a RAM location, and suppose the second number is stored in 2051, and after comparing, the larger number has to be stored in say 2052. So what we do is we'll use the comparing instruction. As you know, there are comparing instruction which can compare the data in any one of the register, which can compare there are instructions to compare the data stored in memory location, but of course that the memory address of that memory location should be in the HL register pair, and there can be instruction for immediate comparing, that is immediate data. Okay, so and always all kind of this comparing instruction is always performed with the data in the accumulator. So it is obvious in 8085 microprocessor that any one of the data or operand must always be in the accumulator. And as you know, the comparing instruction is similar like subtraction instruction, because the primary operation is performed is the subtraction, but in case of comparing instruction the result is discarded. So that means the accumulator content remain unchanged. And accordingly the status flags were affected, and looking at the flag we can say whether the number in accumulator or number in another register or memory or immediate data is greater or smaller, larger or smaller. So the algorithm is something like, suppose x1 and x2, suppose this x1 and x2, these two are the data to be compared. That is to find which one is the larger of this. As you all know, what we do is we always do the operation subtraction. So what we do, we'll subtract x1 minus x2. If x1 minus x2 gives a result 0, that means both are equal. If not equal to 0, then if result is positive, then x1 is greater than x2. If result is negative, then x1 is less than x2. So in 8085 microprocessor, what we will do is first let us assume that both are never equal. That means we will put the numbers unequal. That means x1 and x2 suppose not equal. Assume that at the beginning. So this is anyway x1 is not equal to x2. Now we are going to find whether x1 or x2 is larger. So what we will do, we will put any one of these data into the accumulator. So let us put first number 1 the data x1 into the accumulator. So then this data second data can be anywhere in the register or in the memory whose address is in HL register pair, or it can be immediate data, but since it is a modular program, we'll avoid that immediate data. Okay, so then what we'll do, we'll use the comparing instruction. So after comparing instruction, since I assume that these two are not equal, so result may be either positive or negative. If positive, the carry flag will not be affected. I mean, carry flag will remain 0. If negative, the result is negative because x1 I have copied to the accumulator, and in comparing instruction, it does the operation subtraction always from the content of the accumulator minus the content of the register or memory or whatever, always from the content of the accumulator. So if the result is positive, that means the content of the accumulator is greater. If the result is negative, that means the content of the accumulator is smaller, so the other is greater. So what we'll do is, after comparing, we'll look at the carry flag. So for looking at the carry flag, the instructions are either jump on no carry and jump on carry. If there is a carry, what we'll do, if there is no carry, that means the content of the accumulator is larger, so we'll store that larger number which is now in the accumulator to this memory location. And if there is a carry generated, that means content of the accumulator is smaller than the content of the register or memory, then we'll copy that to the accumulator and store the result into the 2052. So that is the procedure. Okay, so in all this kind, it is better to use the LXI always, the LXI instruction. So LXI H. Why actually LXI H always? Because the LXI instruction can be LXI B also, LXI D also, LXI SP also. But LXI H means, as I mentioned, that if the memory address is stored in HL register pair, then only that memory location can be considered as the virtual register M. Otherwise, not. Means not with the other register pair like DE or BC. It is only if the memory address is in HL register pair only, then only that memory location can be considered as your virtual register M. So my first number is in 2050, so I'll put 2050 here. That means at this instruction, this memory location 2050 is loaded in HL register pair. That means L will be loaded with 50, H will be loaded with 20. So after that, and as the first data is in 2050 and 2050 is now in HL, so because now your 2050 memory location is your M. So from that M, you copy your first data to the accumulator. So move A comma M. Okay. So once the first data is copied to the accumulator, then you just simply increment the HL register pair. Once the HL register pair means INX is executed, that means HL register pair get incremented by 1. So HL register pair now becomes 2051. So now your M, capital M, becomes the memory location with the address 2051. So in the 2051, your second data is there. So next you can simply compare CMP M. So this CMP M, what it will do? It will basically subtract, operation wise it will subtract the content of the memory location whose address is in 2051 or whose address is 2051, that is presently in the HL register pair, from the content of the accumulator. Okay, that means if we say x1 is in accumulator now, x2 is in 2051 memory location. Okay, now after this comparing, if I look at the carry flag using the jump on no carry, suppose jump on no carry line 1, that is just the level, L1 is just the level. So that means if there is no carry, then the content of the accumulator, no carry means content of the accumulator is greater, because the result will be positive, then only there will be no carry. If the result is positive, then the content of the accumulator is greater than the content of 2051 memory location. Okay, so that means your larger number is in the accumulator. Suppose there is no carry. First we consider there is no carry. The given condition is true. Okay, so let me this first. So you need to simply store the result as the, because the accumulator is holding the larger number. So directly you store the content of the accumulator into the memory location 2052. But if there is a carry generated, then it will not jump. If there is a carry generated, then it will not jump. Okay, suppose there is a carry generated. When carry is generated, that means what? Content of the accumulator is smaller than the content of this M. That means 2051. So therefore your larger number is in your M, means the memory location whose address is in HL register, but that is your 2051 in this present case. So what you need to do is you need to copy that to the accumulator. So simply move A comma M. So once you copy it, to the accumulator, then if there is a carry generated, then you are copying. So therefore your larger number is again in accumulator. If there is a carry not generated, no carry, yes, then it will not execute this. It will directly go to this. Okay, because already if this condition is hold true, then the accumulator is already having the larger number. So then it stop it. That is hold. That's it. Okay, that's it for a larger number. Similarly, for a smaller number, I am copy and pasting the same program. Okay, so for the smaller number, the process is again same. So the first data is in your 2050. That 2050 is loaded in HL register pair, and then this 2050 memory location now can be your M. So copy that content of that M, that means content of the 2050 memory location to the accumulator. That is first data is now copied to the accumulator. Then INXH, the HL register pair becomes 2051. Then CMPM. Now at this point, after comparing, if there is a carry generated, so instead of JNC, I'll use now JC. So if there is a carry generated, JC means it will jump if carry is generated. So if carry is generated, that means what? Carry is generated means the content of the accumulator. After this carry is generated means the content of the accumulator is smaller than the content of M. So where is the smaller number? Smaller number is in accumulator. So if carry is generated, so directly go to this. Directly store the content of the accumulator to 2052 because accumulator is having smaller number. Now if this condition is false, that means no carry generated, then it will not jump, it will execute this. So if there is no carry generated, then it will not jump. If no carry, that means accumulator content is already small, accumulator content is larger than the content of M. So we are looking at the smaller number, so smaller is in M. So copy that M, content of M to the accumulator and then store it. Okay, so that's it for the smaller. Now we'll see how to find out the largest number in an array of 8-bit numbers. Okay, suppose the array size is n. N can be an integer, say for example 5 numbers. So n is equal to 5. So that means from the 5 numbers, 5 8-bit numbers, we'll find the largest one. Okay, so first you need to put the counter into any one of the register. So counter means the array size. So for that, as it is mentioned, the n is stored in memory location 2050. So I'll use again LXI. So LXI is 2050. So this 2050 memory location is now stored in HL register pair. So that 2050 memory location becomes your M, virtual register M. Now in 2050 your size of the array N, capital N, is stored. Now I am copying that to some registers, let it be C, comma M. That means the register C is now holding your array size. Okay, then I simply increment this HL register pair. So HL register pair becomes 2051, from which your data will be stored. Now while it is largest, when it was the larger of two numbers, is very simple. One number you just copy to the accumulator, and another number in M or the memory location whose address is in HL register pair, and then simply compare, and depending on the carry flag you can find which one is the larger or smaller, the accumulator content or content of the M. Now it is in this largest or smallest, it is from an array of number. So therefore what we have to do, the same process should be repeat. Suppose there are x1, x2, x3, x4, x5. Suppose m is equal to 5, I mean n is equal to 5. If n is equal to 5, suppose in 2051 x1 data, 2052 suppose x2 data, 2053 x3 data, 2054 x4 data, 2055 x5 data. So now what it will do, first data will be copied to the accumulator, that is x1 is copied to the accumulator. Then x2 is in your memory location whose address in HL, that is your M. So then it will compare both two using the previous your larger or smaller this program. So once it is compared, the first two data x1 and x2, then the larger, right now it is larger, so the larger one will be stored in the accumulator, larger between x1 and x2. Then in the next step, then next iteration, that larger number of the first x1 and x2 will be compared with x3. Okay, and again the larger will be stored into the accumulator. Again that result is compared with x4, and so forth. It is continuing. That is the procedure. Okay, so therefore this counter I am copied to the register C. Now incrementing HL register pair, so it becomes 2051. Then I am copying that first content of the 2051, that is my first data, to the accumulator. Okay, to the accumulator. Then so first data gone, because it is, suppose there are 5 data, so first data gone, so we need to decrement the counter. So this here M. Okay, this here M. This here C. So this here C, it will decrement the content of C. So C is suppose 5, for example, your capital N is your 5 numbers of data, so C was loaded with 5 at this stage. So this here C means C becomes 4. So then again further I will increment the HL register pair. So then it goes to the next memory location, that is 2052. In 2052 you have the third data, that is you have the second data x2. Okay, so now you are comparing that data x2 CMPM. Okay, once you compare, then again the same procedure, only jump on no carry for the largest. So jump on no carry, say line 1. Okay, so where will be the line 1? Line 1 will be your next memory, it has to go to the next data. Otherwise, suppose there is carry generated, it is jump on no carry. So if carry is generated, suppose no carry is false, that means carry is generated. If carry is generated, then the content of the accumulator is smaller than the content of M right now. So what you need to do is, you need to copy that larger number to the accumulator. So move comma M. Okay, otherwise you need not to copy it. because already larger is in accumulator if no carry. So if no carry, that means larger is in already accumulator, so directly jump to this. So what you need to do is, because the first two comparison is done, so you need to decrement the counter. Okay, decrement the counter, and this process will continue. This process will continue from this. This process will continue till C becomes 0. So this is what is looping in assembly language program. Okay, so there is no for loop, while loop kind of things. Using these only you have to maintain the loop. Okay, so the CRC, what you need to check is, you need to check whether that A becomes 0 or not. Jump on no 0. If no 0, that means suppose C was 5, that means your counter N is suppose 5. At this stage, first stage, it becomes here becomes 4 because first number gone, second number compared with the first number. If carry, then the content of accumulator is, ultimately objective is to have the larger number of the first comparison x1 and x2 into the accumulator. Okay, if carry is generated, then accumulator is smaller, so therefore larger is in M is copied to the accumulator. If no carry, that means no carry is generated, so accumulator is already having larger, so directly go to the third number. So for getting third number, you are decrementing the counter, so now it becomes say 3. So jump on no 0, yes it is 3, so no 0, so you need to go back to this. You need to go back to this. Okay, so then what will happen? Suppose it is 3, so it will go to this INX is, that is again incrementing, so it will go to 2053 now. So again it will do with the x2 data, x3 data. Okay, and that way it will comparing, and finally your result is in accumulator. That is your largest number is in accumulator. So finally you need to just store accumulator in largest number has to be stored in 3050. So directly you store in 3050, or otherwise in a consecutive memory if you would like to store, then here again one more INX in mov a comma m comma a. Okay, that's all. Hope you understand. Now coming to the smallest number. So for the smallest number also the same thing only, as I mentioned in the smaller and larger after than smaller. So same thing only here also. Thing is, you need to change this jump on no carry to jump on carry. That's it. So here again the HLA step is held with the 2050 memory location, so that memory location now can be considered as M, where I am storing my N direct size, that is now copied to C. After that it goes to the next memory location, that is 2051. Then the first data which is there in the 2051 copied to the accumulator, then one data gone, so counter is decremented. Then further HLA step are incremented by 1, so it becomes 2052 compared with. Now if jump on carry, that means it will jump only when there is a carry. So when there is a carry, the smaller number is in accumulator, so directly go to the next data. But if it is no carry, then it will not jump, because the instruction is JC. If there is no carry, it will not jump. Then where is the smaller number? Smaller number is in M, so copy to the accumulator. So finally this again this CRC jump on no 0, so it will form the loop. Within that loop it will compare all the does, and finally the smallest number is in accumulator, and finally it stores the smallest number into say 3050 memory location. Now I am going to write the same program for the largest and the smallest in a slightly different way. Okay, So let's see how we can write slightly different way the larger and the smaller. So this was largest and the smallest. So this was the largest. Earlier we have written this program for the largest one. Okay. Now the same only with slightly different. So this LXI H, it will load the HL register pair with 2050, and where as like this case also, where the counter n or the array size n was stored in 2050, that is copied to C. Here also the same thing I did, so copied to C. Then what I did is, instead of directly incrementing and getting the data into the accumulator, then this here and then comparing, what I did is sub A. So why sub A? For clearing the accumulator. In one of my previous program, I have mentioned here as exarray A to clear the accumulator. So for the clearing the accumulator means to make accumulator content 0, lot many ways are there. Number one, we can put like MVI A, 00. Of course, that is a 2-byte instruction with 70 state. Then what we do is exarray A, that is XORed with A XORed with A, which is 0, that is 1 byte 40 state. Similarly, SUB A also, which is also 1 byte 40 state. So this way also A minus A make the accumulator 0. Also we can do A and I ended with 00, A and I, 00, that also make accumulator 0. So there are different ways to make accumulator 0. Different instruction for clearing the accumulator 0. So here I am using SUBA. You can use exarray also, MVI A, 00 also, A and I, 00 also. Okay, to make accumulator 0. So once the accumulator is 0, then I am incrementing an HL register pair, so it becomes 2051. So in my 2051, my second data is there. Okay, so sorry, first data. Because 2050 is having the n and 2051 onwards the data. So 2051 my first data, that is say x1 is there. Now comparing m. So it will compare A, content of A with content of m. M is the memory location whose address is in HL register. That is now 2051. So in 2051 my first data is there, data 1, and in A 00. So with 00 data 1 is compared. Of course, data 1 is greater than data 00. So as jump on no carry. If there is no carry, then go to this, but there will be a carry generated because 00 minus data 1. So the carry, if the carry is generated, that means that the data 1 is greater than the content of the accumulator, because content of the accumulator is right now 00. So then that data 1 is now copied to accumulator. Okay. So then I decrement the counter. So counter, suppose there are 5 numbers, so it becomes 4 here. Then it goes to this jump on no 0. Yes, it is no 0. It goes to line 2, that is level 2, that is INXS. So it becomes now 2052. So in my 2052, data 3 is there, data 2 is there. So then compare m again. So in accumulator, data 1 is there. M means now 2052. So it compares data 1 and data 2. Again, if carry is generated, that means data 1 is less than the data 2. So it is copying data 2 into data accumulator. If there is no carry generated, accumulator, that is data 1 itself is the greater, larger than data 2. Okay, so this loop will continue, and at the end you will get the largest number in the accumulator. Okay, and it's stored in this. So if you compare these two programs, so it will be better to use this program, because this program will have less number of byte as well as the machine state is also less, that is total time of execution is also reduced. So as like this largest, similarly the same can be for the smallest also. Instead of that JNC, you need to put JC only, as explained earlier. So this is the efficient program for smallest, more efficient than this. Okay, for smallest. Okay, next we'll go for the ascending and descending. Okay. So first we'll see the descending order from the largest to the smallest. Okay, descending order. again same thing, suppose n number of datas are there, an array of size n which is stored in 2050, and consecutively from 2051 datas are stored. And after arranging, suppose in the same memory locations only you need to store the descending order data. Okay, here I am showing one example. Suppose in 2050 5 is stored, that means my n is 5. Okay, then what I did is so let it be your 25, this is suppose your 36, then this is your say 42, then this is your 56, I say 15 for example, and this is your 56. So these are the 5 different datas there in your 2051, 2052, 2053, 2054. After the execution, this is before execution, so this part is before execution. Now, so after execution, what will happen? This 2050, this is the counter, it will remain same, but after execution, so it will in the descending order. That means here it will, the maximum of this is 56, so here 56 will come. After 56 it will be 42, so here 42 will come, and then at 2053, say your next data is your 36 is come, then your 25, then 15. Okay, so that way, that means in the same memory locations only, so you are arranging after, because after the execution of the programs, this data will be arranged within the same, arranged in a descending order within the same memory location, say 2051, starting from 2051. Okay, so this is suppose after the execution, this is before execution, this is after execution. Okay. So same way we'll start with this LXI 2050. So each register pair will be loaded with 2050. Then there, as I mentioned, there this 5 is your, that is your n. So 5 is copied to C. Okay, so let C becomes 5 now for this given example. Okay, now the counter is in C now. So what I did, because it is arranging within the same, so immediately I am decrementing the C to 4. So decremented by 1, so C becomes 4, and that C is now copied to D. Okay, C now copied to D. Since we need this kind of sorting or arranging is something like a bubble sort. So what will happen, at first it will make the smallest number in the last memory location, that is 2055 in the first loop, then it will be discarded in the second iteration. This part will be executed where you will get the second smallest number, that is in this case 25 will be fixed in 254. Then in the third iteration this will run, and after the third iteration 2053 will hold 36, then next iteration 2052 will hold 42, and last 2051 will have 50. It is kind of a bubble, from bottom to the top it goes up. Okay, that is why it is called bubble sorting, actually bubble sorting. Now why 2 loop is required? Because every time what will happen at the beginning, this data will be loaded to the accumulator, as like we did in the previous largest and smallest. So what it will do, it will find the largest one first. So this 25 will be loaded into the accumulator. So as like it is doing here in the previous larger and the smaller, largest and the smallest, what it will do? It will first load into the 25. 25 is loaded into the accumulator. Then along with this, it will compare. So in between these two, it will find the larger one. Larger one will go to this memory location, means in the first iteration 36 will go here, 25 will go here. Then that is inner loop. I am talking about the inner loop. Within the inner loop, first iteration 36 will go here, 25 will go here. Second iteration 25 and 42. So 25 goes here, 42 goes here. That is larger one. So then next iteration 25 is here, 25 and 15. So 15 is smaller, 25 is greater, so 25 will remain here, 15 will remain here. Then in the last iteration, compare these two, 15 will go here, 56 will go here. So at the end, that is the within the inner loop completing for the outer loop, outer first loop, 15 will be here. Then go to the outer loop 2. While in outer loop 2, this will not be considered. Then it will start from this to this, okay, and so on and so forth. It will continue. So therefore, we need to have two looping counter. So one is in C, one is in D. So that is why move C, M. C becomes 5. Then immediately we decrement it to 4. So C becomes 4. And same is copied to D. So D is also 4 now. Then I am incrementing INX. So I'll mention, actually it should not be INX. Let's see what happens if it is INX. Okay. So simply INX becomes, itself becomes 2051. That means my M now 2051. Then move A, M. So from 2051 it will copy to accumulator. So in 2051, what it is? 25. Okay. So 25 is now loaded into the accumulator. Then INX it becomes 2052. Now compare M. So accumulator and the content of 2052 will compare, because M means the memory location whose address is currently in HL, 2052. So it is A is your 25, 2052 is your 36, 2052 is your 36. So in between these two, it will find a larger one. So jump on no carry. Jump on no carry means it will jump only when there is no carry. But it is 25 minus 36, so there will be carry generated. So it will not jump. Since it is not jumping, move. I am copying that data, that is larger data, to the B. So B is now copying from M. What is M? M is 2052. So from 2052 it is copying data to B. So what is there in the 2052? 36. Okay, so 36 is copied to B. Then move M, A. So just altering the data. 2052, M is 2052 coming from A. What is A? A is 25. So 2052 will now have 25. Okay. 25, yes, 25. Then what I did, DC axis. So one memory HL content get decremented by 1. So HL was 2052, now it becomes 2051. So move M, B. So 2051 is now B, because there is no instruction for copying data direct from one memory to another memory. That is through B I am copying. Okay, as you know, there is no direct data transfer between memory, one memory to another memory. So 2051 from B. So 2051 will be loaded with B. What is B? B is 36. Okay, then INX is, so INX again become 2052. So again I am maintaining the 2052. So then this CRD, that D is your inner loop, C is your outer loop. So D becomes 3 now. D becomes 3 now. So at the jump on no 0, yes, no 0, it goes to line 2. So at this point, once this first iteration of the inner loop D get finished, so what you will get 2051, 2051, because as I said larger will go up, so 2051 will have here 36 and 2052 will have your 25 after the first iteration. Okay, so then this goes jump on no 0 line to yes. So this is inner loop iteration 2, inner loop iteration 2. So now your HL is 2052, so move a comma m, that means it will come from 2052. So what is there in the 2052 right now? 2052 is right now having 25. Okay, so A is now having 25. Then INXH, so it becomes 2053. Okay, then CMPM, so it is along with the 2053. So 25 is in accumulator and 2053 is now 42. Okay, so 2053 is 42. Okay, now jump on no carry. If carry is equal to 0, then no carry, then only it will jump, but again it is 25 is smaller than 42, so carry will be generated, it will not jump. So move B comma M. So what is M? M is 2053. Same process, 2053 to B. So what is there in the 2053? 42. So B will hold 42. Then move M comma A. So 2053 comes from A. So what is A? A is here 25. So 2053 will hold 25. Then decrement it by 1. So it becomes 2052. Then 2052 will hold B. B is here 42. B is here 42. And HL now becomes again 2053. Okay. So at the end of this, again this here D, it becomes 2 now. So again it goes to here. So when it goes to here, you will get this your 25 and 42. So here 2052 will have 42 and this will have 25. Okay, now 2053 is having 25. So at this point it is 2053. So move A comma M, that is your 2053 now. So again 25 is there, 2053. So at this 2053 it is 25 only. So then that 25 again copied to the accumulator. Now HL becomes 2054. Now 2054. So 25 minus 2054 is 15. 2054 is 15. Okay. Now jump on no carry. Now 25 is greater than 15, so there is no carry generated. So this part will now not executed. So directly it goes to line 1. Okay. So line 1 is this CRD, so it becomes 1. Now at the end of this third iteration, 2053, your accumulator, that means it is 2053 is having 25 and 2054 will have 15. So 2053 will have 25 and this will have 15 after the third iteration. Okay, then again it goes to here. So now it is 2054 because after it was 2054 at this point after before comparing. So it becomes now in the next iteration it becomes 2054. So now 2054, what is there in the 2054? 2054 is 15. Okay, so 2054 is now 15. So 15 is copy it to A. Okay, now it becomes 2055, 2055. So A minus 2055, so it is 2055, it is A is your 15, 2055 is now your 56. Okay, so it is your 56. Then 15 minus 56, example no carry. If yes carry is generated, so it is moving B comma M. So M is your 2055. Okay, so from 2055 data will copy to B, which is your 56. Okay, then M comma, so it is M is your 2055. Then A, so what is A 2055? A is your 15. So 15 will go to 2055. Then the CX, so it becomes 2054. Okay, 2054. Then move M comma B. Your M becomes now 2054. In 54 it is B. So what is B? B is your 56. So 56 will come here, and it becomes again 2055. Okay. So after this loop, your 2054 will have 56 and 2055 will have 15. Okay, so that means the lowest number goes to the last memory location 2055, smallest number. Okay, now at this point, after this DCRD, so DCRD means it becomes 0 now. So jump on no 0, no, it is 0 now, so it will not jump to L2. Okay, it is not jump to L2. So then it will be DCRC. So what was C? C was 4, now it becomes 3. Jump on no 0, yes, it goes to line 3 again. Okay, so now it will be for 3. Now see, this outer loop is now 3. Now again if I put INXH here, so it is now last stage of HL is 2055. So if I now again INXH, that becomes 2056. But here we don't have after 2055 means 2056 we don't have any data. Okay, so therefore it should not be INX. So better you put it as LXI H comma 2051, because at the beginning INX also make it 2051, so LXI, which is the same meaning. Okay, so it should not be INXH, it should be 2051. I mean LXIH 2051. Then the same thing will repeat for 3 times now, because C becomes here 3, and at this stage move D comma C, so now D becomes your 3 now. Okay, your inner loop D becomes 3 now. So this now will go for 3 times. Okay, so since again the LXI is 2051, so HL will 2051, so it is again starting from this, but it will go up till 2054. Okay, 2054. So within this iteration, so what will come here? It will come here 25. So again in the next outer loop iteration, it becomes your 36, and then it becomes your 42, and it becomes your 56. Okay, and finally you will get this. Okay, once this C becomes 0, so that way it will go on. Hope you understood. Okay, hope you understood this. Please go through again once more again, then you will get to know properly. Hope you understood. Then the same thing, if it is ascending order, that means as like here what we did is In the first iteration, the lowest smallest number stored in the highest memory location, that is at the bottom. Okay, and then so and so forth, that is following. So here what we will do is just do the opposite in the smaller ascending order. Ascending order means from smaller to the smallest to the largest. So therefore, instead of jump on no query, simply if you put JC, all the rest of the things will be remain same. Okay, all the rest of the things will remain same. Only thing is you need to put so the same program, only thing is instead of this jump on no query, it will be jump on query. That's it. Otherwise rest all will be same. Okay, so accordingly it will give you the data in ascending order. Okay, so comment will slightly different. I'll make this comment correct and will send you the final program along with this video. So hope you understood. This is today what we did is the comparing. That is how we do comparing and arranging the different data. So we have started with the finding out the larger and the smaller of two data. Okay, larger and the smaller of two data, then largest and the smallest of array of data 8-bit, then ascending and descending of array of data 8-bit. Okay, thank you. For any further query, contact me. Thank you for listening.